Okay, so let's do a quick problem based on the things that we were discussing about torque slip characteristics in the previous few videos. Hopefully, this will clarify some doubts. So this is just a plus sign. Okay, so you can pause the video, look at the question, try to answer the question yourself, and then if not, we can always come back and verify. Okay, so I'll begin the solution. So first, what do we have here? A 764 kilowatt three-phase 50 hertz 16 pole induction motor. So we have an induction motor, and poles is given, frequency is given. Okay, so poles is 16 and frequency is 50 hertz. So straight away I can calculate the synchronous speed. It is 120 F by P. So this is 120 into 50 divided by 16 poles. Okay. So what is the division? So 4 goes 30 times, 4 goes 4 times. So 1500 divided by 4, 4 3s is 12. One more 30, 4 7s is 28, 24 5s. Okay. So 375 RPM is the synchronous speed. Okay. So NS is 375 revolutions per minute. Okay. Uh, Full load torque is obtained at 360 RPM. Okay. So what is the slip at 360 RPM? Slip at full load is nothing but NS minus NR divided by NS. So that is 375 minus 360, because at 360 uh, the full load torque is coming, so that by 375. So let's do this calculation. 15 by 375. Okay. So I would need the calculator for this. So 15 divided by 75, so I get 0.2. Oh sorry, 375. 15 divided by 375, so I get 0.04. Okay, 0.04 or 4% slip. This is at, it's not chip, slip at full load. So let's continue. Calculate the ratio of maximum to full load torque. Okay. So the question that is being asked is, what is the ratio of TFL by Tmax? Okay. So I think just now we have derived it. So this is nothing but 2 into SFL into SM divided by SM square plus SFL square. Okay. So first of all, we need to find slip at maximum torque. Okay. So slip at maximum torque is nothing but R2 by X2. So R2 that is given to us is here 0.02 and X2 is 0.15. So 0.02 divided by 0.15. Okay. So what is this? So again, let's go to the calculator. So the calculation is 0.02 divided by 0.15. 0.02. So it is about 13.33%. 0.133 or 13.33% slip. Okay. So now I have everything. I can just calculate this. So TFL by Tmax is equal to 2 into 4 into 13.33 divided by. So by the way, I can use the fraction or I can use a percentage, because the units are all square units in the denominator, square units in the numerator, so it doesn't matter. So 4 SM is 13.33 square plus 4 square. Okay, so let's solve it. I go back to the calculator. So here you can see the numerator is 2 multiplied by 4 multiplied by 13.333. So this is divided by, so I open the brackets, and 13.333 square plus 4 square, then I close the brackets, then I say equal to. So I'm getting 0.55. Okay, so that's what I get from the calculator. So this is the ratio of full load torque to maximum torque. Okay, so the full load, the maximum torque the machine can support is actually 0.55, or if I want to find the reverse ratio, so T max divided by TFL. So I'll get 1 by 0.15. I just do 1 by X on the calculator. So I get 1.81. 1.82 is the ratio. The meaning is 82% extra load it can take, maximum load it can take over and above the full load. Because if the rating is full load is let's say 100 Newton meters, you can actually load the machine up to 182 Newton meters. So there is a, that is the meaning of this particular thing. So induction motor can be overloaded. Of course, the effect is that the current in the stator and the rotor will increase, produce more heat, and it might cause some heating problems, overheating problems. Okay, so that is about the first part. The speed of the maximum torque. Okay, so slip of the maximum torque I already calculated, that is 0.133. So from that I can find out the speed of the maximum torque. So how do I find? So 13 point, or I'll just write 0.1333 is equal to ns, that is 375 minus nr divided by ns, 375. So from this I should find what is nr. So nr is nothing but 375 multiplied by 0.133, okay, and this will have a minus sign, so plus 375, okay, or 375 into 1 minus 0.133. So let's do that. So 13% less than 375 is what is the meaning of this. So let's do that. So 1 minus 0.133333, I get this number. This multiplied by 375, 86% was there. So 325 RPM. So when the speed is 325 RPM, the maximum torque is achieved. Or in other words, when the maximum torque is achieved, speed falls to 325 RPM. Otherwise, 375 RPM was the synchronous speed, you remember. Alright, let's go up. This we have done. Rotor resistance to be added to get maximum starting torque. Oh, this is straightforward. To get maximum starting torque, simply R2 should be equal to X2. So R2 is 0.02. So 0.02 plus some external resistance should add up to 0.15. If this condition is met, I get starting maximum torque. So obviously it is 0.13 ohms. If I add a 0.13 ohms, then it creates a maximum torque. So this is the answer for this question. Okay, I think you got some idea from this. Let's do more problems.